Okay, so let's look at how the steam engine works in terms of energy then. What did we have? We started off with a fuel. That was our methylated spirits soaked into that cotton wool ball. Okay, we burned that, so that's combustion. Okay, that's a chemical reaction called combustion, very exothermic, creates or generates, releases a lot of heat. Okay, we used that heat to heat up that water that was in the boiler. That went on to cause the flywheel to rotate. So we started off with the fuel, we heated up some water, and we ended up with some motion. In terms of energy stores, fuel, well, that that's reactant in the chemical reaction. So we're dealing with a chemical store of energy. Okay, so that's what we started with. That's where the energy came from to make the steam engine work. Okay, so we're starting off with chemical store. That's our input, if you like. Now, that chemical store of energy was transferred to a thermal energy store. As the fuel combusted, energy was transferred from the chemical store of the fuel to the increased thermal energy store of the water. And we did that by heating. So the boxes are my stores of energy. The arrow is my pathway. The pathway between this store and this store is by heating. Okay. We went from that energy store to our movement of a flywheel. Okay, when we've got movement, we've got a velocity, so we transferred from our thermal energy store to our kinetic energy store of our moving flywheel. So that's our flywheel. Okay, and we transferred that energy using a mechanical pathway. We used a mechanism. Okay, so the boxes are energy stores, the arrows between the boxes are pathways. We can move energy from one store to another. We can, rather than move it, it's better to say we've transferred it. Okay. Now, not all of the energy that we put in ended up as useful output. Okay, if you think about our energy going in as the root of a big fat arrow, let's say we've got a chemical store of fuel that is 100% as represented by the thickness of this arrow. Some of it ended up as useful output. In this example of a steam engine, the useful output is motion. Really, we want to get some kind of motion out of this, so our useful output is our kinetic energy of that flywheel, and I'm guessing that was about 20%. I don't really know, but let's say that's 20%. Okay, a lot of energy was transferred instead to the surroundings. Okay, as heat. Okay, we lost a lot of energy to the surroundings, so heating of the surroundings, i.e. not useful, we might describe it as wasted, but not disappeared. Okay, that needs to be 80%, because if we've got 100% at the start, we need to have 100% at the end. Okay, 20% as useful, 80% not useful. In this instance, I'm kind of guessing, maybe it's worse than that, maybe it's a bit better, I have no idea. Okay, but we always lose some energy to the surroundings. It ends up heating the surroundings one way or the other via friction, or via just those flames weren't just heating the water, they were also heating up the actual metal boiler itself. It was heating up some of the air directly. Okay, some of that heat never got into that water at all. Okay, so we talk about wasted energy. Okay, it's just energy that is not useful. Okay, we could describe this as 20% of the chemical store that we started with has been transferred to useful output, which is our kinetic energy in this instance. 80% has increased the thermal store of the surroundings, okay, which is not useful in this instance, and we might describe it as wasted. If we wanted to quantify the efficiency, we can use the equation efficiency equals the useful output divided by the total input. We could do this using actual values for energy. We could use, this could be in joules. Okay, we can calculate efficiency in terms of power. Okay, if we wanted that as a percentage, we need to remember to multiply it by 100. Okay, so in this instance, we've already got 20 out of 100 units being useful output. So my efficiency in this case would be 20 divided by the total input. If I multiply that by 100, I get the 20%. Okay. Okay. Now we've only used a few of the stores. There are 8 energy stores that you should be aware of. So we've got chemical, thermal, kinetic. That's 3. Can you think of the other 5? If you can't think of them, look them up. Okay. There should be, you should know 4 pathways. We've only used heating and mechanical. There are 2 others. Do you know what the 2 others are? Okay, go and challenge yourself. 8 energy stores. What are they? 4 pathways. What are they? If you don't know, go and look them up.